Hi class, so we're doing 7.1 now, moving on to the last chapter of the, well, I should say second to last chapter of the semester, and we're going to be solving trig equations. So just like we did algebra with, lines, with quadratics, x squared, and then also we moved on and began the semester we did logs and exponentials. We can do algebra, solving equations with trig functions as well. And we're going to be using all of our knowledge of the unit circle, but we're also going to be using a lot of knowledge of these special trig identities. So let's talk about what an identity means, and then we'll start getting practice solving trig equations. So the main difference between an identity and an equation is that an identity is something, a trig identity, or just an identity in general, is something, it is an equation, but it holds true for all values of the variable. So what that means is that it's not like we're solving for x when we have an identity. It's like this is something that's always true. So for instance, x plus 2 is always equal to x plus 2, right? There's no solving there. This left side is always equal to the right side, no matter what. So that's called an identity. Not an equation so much, okay? It's a special type of equation. So let's make sure we're understanding what I mean by identity versus equation here. So down here at A is 2x plus x equals 2x plus 2. Is that an equation? So it has one answer, only one answer for x, or is that an identity? Well, that's definitely an equation because that left side does not equal the right side all the time. It's only true for a certain value of x, which will be whatever, 3x, so 2. Okay, so that's an equation, not an identity. What about over here though? 2 times, let's do B first. So B is 2x plus x equal to 3x. Is that an equation or is that an identity? Well, that is definitely an identity because 2x plus x, you just combine like terms, that's 3x. So 3x does equal 3x all the time. So I'll say for all values of x. So that means it's an identity. Okay, and then down here for C, x plus 1 equals 2x plus 2. There's nothing we can really do here to make this look like the same because I could factor out the 2. But that's not the truth. That's not always the same, right? Left side here looks different than the right side. The right side is being multiplied by 2. So that's not an identity. That's an equation that we'd have to solve. Okay, that'd be x is negative 1. Okay, and let's continue on. So D, 2 times x plus 1 equals 2x plus 2. So see, this right now doesn't look the same, but if I distributed it through, then I would get 2x plus 2. Does that equal 2x plus 2? Oh yeah, you betcha. So that's left side equals right side. So that's true no matter what value of x I have to solve for. And so that's an identity. Okay, and E, let's make sure my mic is right. Okay, and E, sine 2x, does that equal 2 sine x cosine x? So this doesn't look like it's true, and this is just, you don't have to know this yet, but this turns out that this is an identity. This is always true. So this is called the double angle identity for sine. Okay, so it turns out that is an identity, so that's kind of cool. And it doesn't look like it here, and there's not a lot of algebra we can do. It takes a lot of trig to actually understand why this left side equals the right side, so we'll talk about that when we get there. And what about this one? Sine squared plus cosine squared equals 1. Well, this turns out, we've seen this a little bit before, this is an identity. This is called the Pythagorean identity. So this is an identity. This is always true. It doesn't matter what x is. So that's kind of cool. All right. So I summarized for you here some identities that we've had already actually in class. So these are the reciprocal identities. These are just, what we know, cosecant 1 over sine, secant 1 over cosine, etc. So those are all just the definitions of these reciprocals. Tangent is sine over cosine and cotangent is cosine over sine. Pythagorean identities we talked about, sine squared plus cosine squared equals 1. Okay, that's an identity. Remember, that also means like if we subtract sine squared that we can get another identity. So for instance, cosine squared x is equal to 1 minus sine squared. You can move stuff around, okay, etc. All right, same thing here. If we wanted to solve for tangent squared, this would say tangent squared x, you know, just subtract 1 is equal to secant squared x minus 1. Okay, and if we wanted to solve for like cotangent here, cotangent squared x is equal to cosecant squared x minus 1. Okay, so anyways, those are the Pythagorean identities. They all come from this first, I call this the granddaddy or the grandmama. You can just divide all of these to get the other ones. Cofunctions we talked about. This comes from the acute angles inside of a right triangle. And the even odd identities. Remember, we talked about this. Sine is odd. It's the only one that's odd. So other than that, it's sorry, sine and tangent are odd. Cosine's even. Cosine and secant are the only ones that are even, and then sine, tangent, cosecant, and cotangent are all odd, and so these are odd. Okay, we talked about all this last chapter, so these are just kind of the first ones that we've learned. We're going to have to know these, but luckily, you know, I'm going to provide a lot of these on exam. So during I'll show you the table I've made of you're going to have by the end of the chapter of which identities you need to know. A lot of them I'm going to provide for you. Okay, let's continue on. So let's verify. So let's take a look. So how can we verify this identity? 1 plus cotangent squared is equal to cosecant squared. Okay, so there's some principles here that you want to do. Number one is you want to work on one side only. So what I mean is that you don't want to try to do a bunch of stuff on both sides. It gets too confusing. And also you can't move things around. So like I can't subtract 1 here. So I have to treat this as it's like a big wall. And I put a little question mark. I'm not sure that these are equal. So because I'm not sure that these are equal, I can't subtract 1 on both sides because that's assuming that they're equal. So I can't do that. So number one, work on one side only. Number two, what you want to do is usually, what usually works is express terms in, I'll say with sine and cosine. Okay, so let's take a look at that now. So if I work on this one here, I could work on, let's work on the left side. So I'll start on the left hand side. LHS is left hand side, just abbreviation. So what I see here is I can work on this cotangent. So if I rewrite cotangent as that's cosine over sine, so that would be cosine squared theta over sine squared theta. Okay, and again, I'm only going to work on the left hand side. Now what can I do here? Well, see, I have, so are you okay with this, what I did right here? All I did was I rewrote cotangent as cosine over sine, because that's what cotangent is. And then what I can do is I can get a common denominator. So if I multiply this by this 1 by sine squared over sine squared, okay, then what do I get? Okay, well then I get sine squared then I get sine squared theta plus cosine squared theta all over the common denominator. Okay, hold on, I'm going to pause the video. My Word is acting up. Okay, and we're back. Hopefully this works. My computer's acting a little weird. But anyway, so all I did here was, first step again was I replaced cotangent as cosine over sine squared. and then I got a common denominator. That was just some algebra, just getting the like denominator. And then I just wrote out what the fraction is. But now check it out. I have sine squared plus cosine squared. Hey, we know that. That is equal to 1. That's the Pythagorean identity. And so what I get now is I get 1 over sine squared okay, and we know 1 over sine, that's cosecant, so we have now equals cosecant squared theta. Okay, and guess what, this is the right hand side. Okay, so this is what we were supposed to get to. Okay, so the right hand side. Okay, so there you go. So notice that we only started on one side, and we just follow our guesses, our manipulations to make it so that we get the right hand side. And so we haven't done any. We didn't move anything across the equal sign. That's why it's like a firewall. Okay, you don't want to do anything that moves across that. But I can do everything on one side. Okay. So what I'm going to have to do is I'm going to have to stop the video now because my computer's acting weird again. And I'm going to post this video as part 1, and then I'll put part 2 up as well. But thanks, and make sure, so we're not even close to being done, so make sure you click the next video as well for part 2. I'll try to fix everything that's going on my computer. Alright, thank you. See you at the next video.